Okay, so this is number 8, last question on this extra sheet. And I'm just going to tweak it like I did one of the other videos with, I'm just going to look for theta on 0 to 360 instead of 0 to 90, just to make it a little more interesting. This deals with, again, all your reciprocal trig ratios. Okay, and we're just looking, it's kind of the opposite question to number 7, where I'm provided the ratio and look for the angle in question 8, whereas in the last question we were provided the angle and we found the ratio, right? So with 8a, I have that the secant of theta is going to equal 2. I know that the secant of theta is going to be the same as 1 over cosine theta, has to equal 2. And so I'm just going to multiply both sides by cos theta and re-isolate, right? So I should see that 1 is going to equal 2 cos theta. I'm going to divide both sides by 2. I'm going to arrive at the fact that cos theta should equal 1/2. So I'm interested in where, again, if I draw myself a little picture, I'm interested in where is theta, or sorry, where is cosine positive? And so we're applying our cast rule again. Cosine is positive in the all quadrant, and cosine is going to be positive in the cosine quadrant. Okay, and so subsequently, I should see that adjacent over hypotenuse is cosine. And so what I get is 1, 2, and 2 for both of these triangles. So the only way, which would make this, if this is the 30, 60, 90 triangle, the only way to get that is that if that is 60. Okay, and so theta for this question from 0 to 360 would be 60 degrees, and theta would equal 300, right? Because that would be the 360 minus the 60-degree angle. It would be 300 degrees. Okay, so that's A. Question B. Question B is going to be the cotangent. I'll write the question first and then start working with it. Cotangent is going to equal root 3 by 3. Now that looks like something complicated we haven't seen, but in one of the earlier videos, you could turn it into something. Now, why don't we work with it and just see what happens? So we know that the cotangent of theta is going to be 1 over tan theta is root 3 by 3. And so I'm going to multiply both sides. Well, I could basically cross multiply, if you will. I'm going to get 3 has to equal to root 3 tan theta. And then I'm going to divide both sides by root 3. Oops. And then I'm going to see that those root 3's drop out, and I get tan theta has to equal root 3 over root 3, which again looks a little bit weird, like I don't really know how to work with that at the moment. So what I can do is multiply, I'll just rationalize the denominator to see what happens. And I should see that the tan of theta should equal 3 root 3 by 3, okay? Which then turns into tan of theta is equal to root 3 by 1. So now I'm interested in where is tangent positive, because I haven't seen anything come out to be negative yet, as I don't think we will, because the original question was 0 to 90 where everything is positive. So I think all these questions have been written from that standpoint. But the tangent is positive in the all quadrant and the tangent quadrant, right? So in the all quadrant and the tangent quadrant. Okay, and so what we get here is we know that tangent is going to be opposite over adjacent. Okay, and so I'm going to get root 3 and root, if this is theta, and root 3, 1, that'll actually be negative 1, negative root 3, if you will, and that'll be positive 1. And so opposite of the root 3 is going to be 60. Okay, we actually get the 60-degree triangle again. So I get theta is going to be 60 degrees, and theta is going to be 180 plus 60, which is going to be that 240 degrees. Okay. Okay, question C. This might be a little interesting with the secant squared, so let's see how we manage that. So C, 2 cosecant, oh, sorry, that's question D. Secant squared theta is going to equal 2. All right, so I'm going to square root both sides, just to get rid of that squared right off the bat. So I'm going to square root, and I know when I square root both sides, I have to write the plus minus. So I get secant theta has to equal plus minus root 2. And then I know that secant corresponds with cosine. So I get 1 over cos theta has to equal plus minus root 2. And if I solve for cosine theta, which is ultimately what I'm going to do, I should get that 1 over plus minus root 2 has to equal cosine theta. So not necessarily great because I need, well, 1 over root 2. Well, let's work with that. So I get cos theta with the plus minus business here. Cos theta should equal negative 1 over root 2, and cos theta has to equal positive. I'll move that over. I'm out of room. Draw a line too so you guys can see. Okay. And cos theta has to be positive 1 over root 2. So let's first establish where, cosine is positive and negative. So let's do positive first. I think we're going to get 4 answers here, as you could probably predict. So cosine is positive down here in the cosine quadrant, and cosine is also positive up here in the all quadrant. Okay, and then we're going to get, where is cosine negative? It's going to be in the sine quadrant, and cosine is going to be negative in the tangent quadrant as well. Okay, and so we actually have 4 angles here, and now we need to figure out what actually goes in the angle of reference spot, so the angle between the terminal arm and the initial arm. Okay, so we know that cosine here is saying that it's the components are 1 over root 2, and I know that that is adjacent over hypotenuse in both of these instances. So I know that the hypotenuse is root 2 all the way around, which to me, right off the bat, I know the root 2 corresponds with a 45-degree triangle. So all the way around from 0 to 360, that's why these questions are a little more interesting. From 0 to 360, we should see that 45 degrees should be an answer, 135 should be an answer, 215 should be an answer, and 315 should be an answer. Okay, so there's your answers for that question. Okay, we got one more to do, and that's going to be 2 cosecant squared theta has to equal 8. Make sure that's right. Oh, cosecant squared. That was close. All right. So again, just another solving process. We might actually need more room, so I'm just going to bring that down to the next page here. So let's just do some solving. So right off the bat, I could probably get rid of the 2. And so I get cosecant squared theta is going to equal 4. And then if I square root both sides, I should see, if I square root both sides, I get plus minus. Don't forget that. I should see cosecant theta should equal plus minus 2. Okay, and then from here, the cosecant corresponds with sine, so I should get 1 over sine theta has to equal plus minus 2. And when I go and solve for sine theta, I should see that 1 over plus minus 2 has to equal sine theta. And so we end up at the same position as the last question. We get sine theta has to equal positive 1/2, and sine theta has to equal negative 1/2. Okay, and what we're going to do now is figure out where 0 to 360 these are true. And so I think, again, you could predict that we're going to end up with 4 answers. We should see that. I'm just going to draw 4 triangles here. Okay. If we're following cast, you are actually finding where cosine, or sorry, where sine is positive and negative for this particular question. And that was from the nature of that square root and what we did with it. And again, pictures don't need to be overly accurate. They're just there for you to actually answer the question. And so we now need to figure out if sine is opposite over hypotenuse. The hypotenuse is being told to us as being 2, 2, 2, 2. Now that doesn't totally lock in which of, like I know right now it's either the 60-degree or the 30-degree triangle because of the presence of the hypotenuse being 2. And so I also need that this opposite side length is 1. And I know all the way around here that if the 30-degree angle goes opposite the side length of 1. And so all the way around, we're going to get 30, which subsequently makes all of these angles. Theta is going to be equal to 30 degrees. It's going to be equal to 150 degrees, 210, and 330. And that's it. Okay. So just a way to spice up that last question a tiny bit. 0 to 90 is a little bit boring because you're just going to get one answer, 0 to 90, but 0 to 360 gets more interesting, and you can see that with the introduction of the squareds, plus, minus, and whatnot. Okay, so that's that. That's the end of that extra exact value sheet. I hope all you find all those videos helpful.